Oh, here we go again. This is Ash, and this is a video called Write a Benthos Plugin. And what I'm going to do is I'm going to walk you through the entire process from start to finish. And for the purposes of this video, I'm going to be doing a bit of role play. I'm going to be playing a typical run-of-the-mill data scientist. We all know one. And what I've done is I've actually done something pretty brilliant in this role play. What I've done is I've written a sarcasm detection algorithm. And that can be summarized in this function. So we get some content in, which could be a post or a blog or whatever you want. And what it does is it gives back a result between 0 and 100 as to how sarcastic that content is. Now, this function here is it's too complicated to go into details. There's a lot of stuff going on here. It's probably using some sort of machine learning algorithm under the hood, but we can assume that given a large enough sample of data, we'll see a nice bell curve of sarcasm detections across those fields. So what we want to do now is we want to productize this brilliant work that I've done. And the way that we're going to do that is we're going to deploy it as some sort of stream processing solution. So this thing is going to have to read a continuous stream of data from somewhere and then write some sort of resulting documents out to somewhere else. And we're going to write this as a Benthos plugin. And the brilliant thing about that is we can write this plugin now without worrying about any of these details that I've shown here. So we don't need to know where the data is coming from. We don't need to know what it looks like. We don't need to know what it needs to look like when it's coming out of our service, and we don't need to know where the destination is. So for example, we could write our processor to just work on plain text, and if it turns out later on we need to read from S3 and we're getting these CSV archives, and then we've got to write JSON documents after detecting sarcasm into a Kafka topic or something like that. We don't need to worry about any of that stuff until it comes to deployment, because we can deal with it all in config. And on that note, the other cool stuff that we get out of the box with Benthos is resiliency. So for example, we don't need to worry about dropping data or anything like that. We've got at least once delivery guarantees. We also don't need to worry about back pressure or error handling. Stuff like that is already dealt with through config, things like dead letter queuing, stuff like that. We don't need to worry about horizontal scaling. Again, that can work in config, so our processor can just work on a single thread. We don't need to worry about CPU scaling or anything like that. Also metrics, so we don't need to worry about metrics or logging or anything like that. We're automatically going to get stuff like processing latencies and input throughput, output throughput, stuff like that. We can already make dashboards out of the metrics that Benthos exposes. So as the author of a processor, I don't have to think about any of those things. And then obviously you also get all the other Benthos components. So everything that Benthos has is going to be compiled into this stream processor that I'm about to build in this video. So let's just do it. Let's just get into the code, okay? So the first thing we're going to do is initialize our dependencies. We've got a nice clean, relatively clean repo here. We've just got a main.go file with some boilerplate in it. We're going to use Go modules in this example, but there's no reason why you have to do that. So we're going to say go mod init, and I'm going to call this package foo.com/bar/baz, and that's going to give us our go.mod file. Now I can pull in our dependency. So our only dependency is Benthos. So in version 3, which isn't out yet, you'll be able to use just regular modules. So it'll be Benthos/v3, and that'll just pull the latest one. But currently, for me, the latest is version 2.11. Because that doesn't properly support modules yet, you can still use it with Go modules, but you have to put in an explicit version number here. So I'll say go get. Now for you, if you're pulling all these dependencies for the first time, it'll take a while because you're going to have to go through all the third-party deps. But for me, they're already cached. So there's a little cheat there if you want to copy that. So now we've got a go.mod and a go.sum. If I look at go.mod, so you'll notice that because Benthos doesn't fully support modules, what you get instead is this manky timestamp hash lock. So it doesn't look pretty. So version 3 will look a lot nicer. And that's it. So we can now start doing our code. So this is my current main.go. And what I've got here is my how sarcastic function that I showed you in the slides. I've got this sarcasm proc struct, which is going to be my actual processor implementation. So this is the actual meat of my plugin when it's fleshed out. And then we've got this main, which all this does is it calls Benthos service package.run. And that will trigger the entire service. So if I build this right now, we'll get a binary out of this, which is going to be called Baz. That is a fully fledged Benthos instance with all the same flags as regular old Benthos. So everything that we add in this file now is just adding on to your vanilla standard Benthos instance. Okay, so let's get into the meat of our processor. So this struct here, our job right now is to make this type satisfy Benthos's processor interface. So we can do that quite easily with Visual Studio Code with a go command. When is this generate interface stubs? This command is badass. I only discovered this recently, but you'll see the outcome anyway. So if this doesn't make any sense to you, you'll see what it does. So what I've done is I've just told Visual Studio Code to generate the interface for Benthos processors. So that gives us three functions. So the method process message, I'll come to that in a minute. We've got close async and we got wait for close. Now the purpose of these two is if the component that you're writing has state, so for example connections that it's maintaining, or if it's creating files or something that need to get cleaned up or whatever. Let's get rid of those messages. Then these functions are where you would trigger the cleanup. So close async, this gets called when Benthos is getting ready to shut down. So at the point where this gets called, you can basically stop processing any data and you can start triggering the shutdown of any components and resources that you've got. We don't have any in this case, so that'll stay blank. Wait for close is a call that gets sent by Benthos when it's just about to shut down, like everything else has been cleaned up already. It's ready for the process to exit. This is your component's opportunity to prevent that until your cleanup has finished. There is a timeout, so you're supposed to respect that. These functions, as you might guess, predate Golang having the context type added, and it satisfies a very similar use case, but they still exist for now. But yeah, in our case, we can just leave an empty body for close async and return nil for wait for close. Now onto the process message. So there's more information out there if you want to learn about this interface in more detail, but in a nutshell, we receive a message, and a message in Benthos can have any number of payloads. So this is synonymous with a batch, essentially. And what we're allowed to return is either one or more messages or a response. And a response type can be an acknowledgement, it could be a noac, and also special type unac. But in most cases, you're either going to return an acknowledgement if you're intentionally dropping the message, or it would be a noac or an error in the case where this processor has failed in a catastrophic way and we don't know what to do, in which case, depending on what the input type is, that might route the payload into a dead letter queue or something like that. But the overwhelming majority of cases, you're probably just going to be returning a single payload, which is exactly the case here. This sarcasm detector, there's no catastrophic failures that might occur in this, and we're always going to be sending one message batch in return. So the first thing I'm going to do is we're going to have a result message. So I'm actually, because I'm going to be mutating the contents of the resulting message that comes out of this processor, I do a shallow copy of what comes in. And when we return, we're always going to return that resulting payload and a nil response. So right now, this processor just does nothing. It just passes a shallow copy of the message straight through. And then what I'm going to do is I'm going to iterate. So the message types.message has a method iter, which allows you to specify a function for iterating every payload in this batch. Now you might be wondering, like, why do we do that? Why do I have a message type that has any number of payloads? Why don't I just give you one payload and you can give back any number? Well, the reason why is because it's easy for you as the implementer of a processor to essentially disregard the fact that it's a batch. You just deal with each payload individually. However, if you wanted to do the opposite, like if you want to build a processor that, say, takes a batch of a number of messages and reduces it using some algorithm, or does the opposite. Maybe it takes like a few messages and it expands them into multiple separate batches. So something maybe like a group by operator or something like that. Obviously, it's impossible to implement that unless you're given batches through the interface. So Benthos, within Benthos, all components are kind of like batch aware and able to do cool things with contracting and expanding batches. And this is kind of like a small price to pay, because basically within this, the part interface is essentially your message. So it's got metadata, it's got a payload and all that stuff. So all it means is that when you design your processors, you just, you iterate them in most cases. So this is where we're actually going to do our sarcasm detection. So to get the byte content of our message part, we do part.get, which just gives us the raw bytes. So if I feed that into my sarcasm function, let's get how sarcastic. So there's our result. We've now got a float. And what I want to do is I want to store that result in the payload somehow. Now, there's a whack load of different ways in which you could do that. So for example, we could set some metadata, so we can get the metadata structure and then set, we could set a metadata field to sarcasm, and then we'd convert sarcasm to a string. Let's do that first, actually. Sarcasm string, stack of, what do I want to do? Format float, I think it is. Is it? And then sarcasm, I believe we want to do something like that. Does that look right? Bit size, precision, yep. Okay, so now we've got a sarcasm string, so we can set that as a metadata field. In which case the payload itself of this message doesn't change. We just add a metadata field and that's that. However, I actually want to be a little bit more flexible with this processor, and I'll show you why in a minute. What I'm actually going to do is something a little bit controversial, okay? But don't panic. I'm actually going to set the value of this message part with the string. So what comes in is a payload that is just text. I'm just parsing this as text. I'm detecting the sarcasm, and then I'm replacing the contents entirely with a number indicating how sarcastic the content is. And then what I'm doing is, so this iterator will go through every single payload of the batch, does that, and then we return that batch. Okay, so the next thing that we've got to do, we've implemented our first iteration of our sarcasm processor. We need to let Benthos know about it. So the way that we do that is we register it. And because we're registering a processor plugin, we do that at the processor package. And now I have copy pasted a cheat, so I'm just going to paste that in now. So this is what the call looks like. So we say processor register plugin. The first argument is the name of our processor type. So when you're writing your Benthos configuration, this is the type string that will initialize the plugin type. So we're calling this how sarcastic. And then the second argument, which I'm not going to dwell on for now, is a config constructor. So if we were to have a configuration struct that contains all of our config parameters, then what we would provide here is a function that constructs that with default values. And then when Benthos is generating configs and validating configs and things like that, it will use that as the reference. Then the third argument is this function. So this is our constructor for a Benthos plugin. So when Benthos runs, this will get called for every instance of the plugin type. So it could get called more than once. And what you get is the first argument is an instance of the configuration structure that you provide in this call here. In our case, that's always going to be nil. We don't have a config struct, so this can just be ignored. And then our job is to take that config, which we don't get, and return an instance of our processor. So in this case, I can just literally return a an instance of sarcasm proc, and then a nil error. You can return an error. So if the configuration is junk and you detect that at the point where you construct your component, then you can just return an error, in which case Benthos will print it, and then it'll stop execution and come to a halt. These are the types. So we've got a manager that gives us access to Benthos caches and other resources that we might have, so rate limits and stuff like that. So if you wanted to use that within your implementation, then you're free to do so. The logger is obviously how we might log messages. I'm not going to do any logs here, but we could copy that construct into our sarcasm proc if we wanted to. Same with metrics. So with metrics, we're allowed to register things like counters and gauges and stuff like that, and then that's handled in a generic way. So whatever metrics aggregator you configure, so it could be Prometheus, could be StatsD, whatever, the metrics that we initialize and count in our implementation would then get carried over just like any other Benthos metrics. But for us, we're just going with the basics. This is all we need. So if ever a how_sarcastic component is initialized in Benthos config, this is what's going to get returned. So we can actually try that now. So I can do a go build, and hopefully this will build. Is it going to build? Please. Please build. Okay, and let's write ourselves a config. So I'm not going to specify any inputs or outputs or anything like that. I'm just going to make my processor. How sarcastic. And that's it. We don't have any config params. So once we've told Benthos that we want a how sarcastic type, that's it. So this is going to get run now, hopefully. No, we don't want to do that. We's our new type, and I'm going to say foo bar baz. That's not sarcastic at all. Foo bar baz /s. Oh no, hang on. Foo bar baz /s. Whoa! Sarcastic AF. Up in here. Okay, so that's working. So we now have the ability to return the sarcasm. However, this on its own isn't that useful because A, we're rarely ever going to be just consuming a stream of raw text, and B, we're never really just going to want the number coming out. What's probably more likely is we're going to get something like JSON documents coming through, and then we'll want to add a field onto that that has our sarcasm detection in there. So next, I'm going to show you how to do that. Okay, so let's assume that we're receiving JSON documents. So maybe it's something like content, and then we're going to get some string in here, and maybe we get some other fields or something, but basically it's going to look like that. And what we want to get on the output is a new field, sarcasm, which has our floating value, which is the sarcasm level of our content. So that should be pretty simple. Now, if you're not familiar with Benthos processors, don't worry too much, because that's not going to stop you from understanding what we're doing here, I don't think. So first I'm going to use the Json Processor, which has an operator copy, and the path I'm going to give it is content. So we're going to copy whatever is in the field content to the path sarcasm. So what that's going to do is we're going to have a duplicate field essentially, and you'll understand why in a second, because I'm going to do a process field processor. So the process field processor takes a path, which is sarcasm, and what that does is it extracts the value of whatever's in that path in the JSON document, and then it applies any number of child processors to whatever the content was, and then it replaces the content with the result of those processing steps. So if I just put in my how sarcastic processor in that list, what will happen is sarcasm is the same as our content. The process field extracts the content, replaces it with the sarcasm level, and then that will get put back in to the original sarcasm field that we've copied. So we can try that out. Let's do baz, and then our config field foo. Whoops. So let's try that. So content foo bar baz. And whoa, look at that, on the output we now have sarcasm 0. And if I change that, so if I say content foo bar baz /s, sarcasm 100. Now what you'll have noticed here is that we actually have a string value here. And that's not ideal, is it? We don't want a string in there because it means downstream stuff isn't going to immediately pick it up as an integer. It's going to have to parse it. So we can fix that. The process field processor has a result type field, which is, in this case, a float. And what that means is that whatever the raw result is gets turned into a floating point type again. So let's put in the same payloads as before. So now it's an integer. Content foo bar baz /s sarcasm 100. Right, so cool. So it's the same implementation we had before. Now it's useful. And there's all kinds of stuff we can do with this now. So because it's just changing the raw contents, it kind of makes it more flexible because it means that we can use Benthos processors to kind of decide for ourselves how we're going to utilize the output rather than the processor itself, just, you know, kind of like enforcing that it's going to be in the metadata, for example. We could, however, if we wanted to, have config fields. So just for argument's sake, I'm going to add in a field to this called, let's call it metadata key. That's going to be a string type. I already think that this processor is flawless, but just to demonstrate how the configuration stuff works, we're going to add this in. So metadata key, this is going to be the Sarcasm Processor's only configuration field. Now in this case, I am using the same construct that is my implementation as the config struct. That doesn't necessarily have to be the case. They can be separate, but why not? Why not combine the two? And then what I've done is I've added a JSON key and a YAML key, which are both the same. It's just meta_key. So in order to have that get utilized by Benthos, because as it stands right now, we won't get any config back. What we do is we add in a function here, which takes, what's the format of processor plugin config constructor. Help, I don't know my own code. So that just looks, okay, that's literally just a function that returns an interface. So that's pretty easy to implement. Now this needs to be a reference type. It does say in the documentation. So what I'm going to do is I'm going to initialize our processor. So it's a sarcasm proc. And what I'm going to do is I'm going to give that field a default value. So I'm going to say foo. And then I'm going to return proc. And now whenever you see the how sarcastic type in a config, it's going to have this config field as part of it. But it's going to be ignored right now because it gets returned in this function, but we don't actually do anything with it. So in order to use it, I'm going to have to cast config as my sarcasm proc type. And in actual fact, we can just return that and nil. Obviously, this is going to panic in the case where that's not the case, but Benthos, if it's being good, should always make sure that that is the right type. So we can build that again. And I can actually show you what that config field looks like. So we imagine we've got the same thing. I'm actually going to simplify this processor list. So now we've only got our how sarcastic type. Now Benthos, if you don't already know, has a command where it will print out the same config that you've given it, but with all the extra fields. So I'm going to call that bar.yaml. Oh my god, I did it again. Right, so now we've got a new file, bar.yaml, and this is the exact same config as foo.yaml, except it also includes all the fields that we've omitted. So for example, our standard in input and standard out output, and also the logging and metric stuff. But what you'll notice is in our processes list, pipeline.processes, we have our how sarcastic type, and now it's also got config fields. So now we've got plugin, which is the namespace for all plugins, metadata underscore key, and it's got the default value foo. So if we copy that, we can actually just put that in our foo type. I can change that to bar, for example. Now, metadata fields don't get printed by default. So what I'm going to do is I'm going to add in a log message here after our processes have been applied. So we're going to log the amount of sarcasm in this thing. Okay, so let me explain. So our sarcasm detector now has a field metadata key, and it's going to use that to set the result of our sarcasm detector into a metadata field within the payload, which it's not currently doing, by the way. And then the idea is that when you write your config, you can then expose that metadata field with normal Benthos means. So if, for example, if you were sending this data out to an S3 bucket, the metadata would be copied over as metadata in the bucket item. Similarly, if you send it to Kafka, it would be a metadata field, things like that. But also you can use metadata within a Benthos config itself. So right now I'm just logging a message every time a payload comes through, which logs the contents of the metadata field bar. So we're going to detect our sarcasm, but the payload itself will remain unchanged, and then I'm going to log out what the actual sarcasm level was. So I've got to change my code now because we're no longer outright changing the value of the payload. So I'm going to set the key, which is s.metadata key, with our sarcasm string. And that's it. So now my processor is using that field, and we should be good to go. So if I build that now, go build. And then once that's done, we can use our config value. So if I just, this is raw content again now, so we don't need to put JSON objects in. So foo bar baz, and we get a log message, sarcasm 0, and notice that the payload coming out remains untouched. And then I can follow that up with foo bar baz /s, and we log sarcasm 100. And also out of interest, I can print the config that we just gave it. And as you can see, it's printed that our metadata key is set to bar, as you would expect. So, right, we've written a plugin. We've written a plugin with config fields. We've executed our plugin. We've executed it with a wacky, wild config that does all kinds of crazy stuff. I think that's everything I wanted to show in this video. So if there's more stuff you're interested in, maybe let me know. Or, you know, just stay silent and don't give me any feedback whatsoever. I might make more videos like this, I don't know. Don't know if I can be bothered because it's a lot of work at the end of the day. And I've got a lot of stuff to do. Right, thanks for watching.